I swear.
All right. So, if you haven't noticed, this entire unit is going to be on transformations. So we're going to talk about flipping an object, turning an object, blowing an object up, or shrinking an object, and sliding an object. So we need to first just talk about normal transformations. A transformation. So this first blank is transformation. Is an operation that moves a figure. Okay. A transformation is an operation that moves a figure. There you are, my friend. You're well? Huh? Okay, the new figure. Okay, so once we've moved it, it's now going to be called the image. And your original figure is called the pre-image. Okay, takes you back to English class. Okay, pre means come before. So that's your original. That's a good way to remember it, knowing what that prefix means. Breathe, Tay. It's going to be okay. Okay. Moves. Every time we do a new lesson.
So, but for every single class?
Mm-hmm. It makes it a lot easier when you guys are absent, because then I can say, go watch the video and then come ask me questions.
I got to see how to spell it.
Okay, when we look at the set of points, it's called mapping. Okay, a mapping is a correspondence between sets of points so that each point in the first set corresponds to exactly one point of the second set. And these mappings in algebra are called functions. Oh, look, we talked about functions already. That's one thing about math is it builds. So in other words, if you start to get lost, I need you to come see me so we can get you back on track, or else I'll lose you for the rest of the semester. Okay, an isometry. That word's going to come up again, guaranteed. Okay, an isometry is a rigid transformation that maps every figure onto a congruent figure so that the pre-image and the image are congruent. So in other words, your two figures, they don't get any bigger or any smaller. They just move. Okay. They're still the same size, same shape. They just look different because they've been moved. So if we have an isometry, it preserves length, angle measures, parallel lines, and betweenness of points. Questions so far? All right, now that we've got a background, let's dig a little deeper. So on page 11, I need you, or I'm sorry, 19, my bad. I'm looking, okay. On page 19, We don't technically have a page to glue in here, so I'm going to need you to title this Rigid Transformations. Can we what? The transformations page? Yeah, glue it in on page 18, if you did not do so already.
Wait.
Yeah.
Are you going to edit your video?
Those.
Wait, you wanted a transformation on 18?
Right.
Yes, that transformations page that we just filled out will go in on 18. All right, so we're going to start with the rigid transformations today and just talk basics about rigid transformations. Tomorrow we'll get into the nitty-gritty about rotations and then reflections. Okay. We've got 3 types of rigid transformations. Okay. So what these do is they change the position, so where your shape is, but it does not change the size of your shape. Okay, so we're going to start with your triangle. And what I want you to do is I want you to take your triangle and I want you to trace it. It doesn't have to be perfect. Mine is not by any means. Once you've traced it, then flip it and glue it in beside it. I know, so much. It's so difficult. If you notice, this triangle does not look the same size as that one. By any means.
Same shape.
Y'all got this. I got a lot of faith in you. Kind of scary. Should we glue in all the shapes first before we
Yeah.
All right. So underneath that one, take your what is this? Trapezoid. Ooh.
I was gonna say that, but then I thought it was a pentagon.
It is a trapezoid.
I was going to say
That's down.
that.
It's 8 squares. It's 8.
A pentagon is 5.
Ain't it like that?
A pentagon is 5.
It's not like a house. She thought this was a pentagon, so that's even worse than what I said.
It's like the same shape. Will it matter which one you put the trapezoid?
No.
Okay, it won't glue down. Can you like help me? It won't stay down.
She's not doing it right.
No.
Probably because we're all out of fan. Oops, I glued it wrong.
Oh,
How you glue? That's what I just did, Kelly. You put it on bars. That's what I did. I glued it down first.
There we go.
What?
Well, I tried to be correct. I follow directions.
Who follows the rules anymore? Do we put that one inside them bush?
Nope. Just slide it.
Oh, yeah, that part.
Oh, it was supposed to be down like that.
Down?
It doesn't necessarily have to go down. It just slide it.
Hey.
So why do you think I'm
Make sure when you do the heart that you turn the heart.
while we trace it, not worry.
No, trace it and then turn it and glue it.
I know you ain't talking. I ain't saying nothing about your secret.
Kimberly.
I can't be great. Yes, I can't be great.
You can't be what? Why?
Excuse him, he has problems.
She said I can't be great. She said I'm not great. I can't be great. See?
Oh my gosh, I'm being honest.
What? I was tough.
What?
Oh, no. It's an itch. Weed, my weed.
I used.
One side of
I had to
the
ask the one year because I had one girl. That
Some
yeah, this-
just like
I was
plain
like,
simple to
what
work
are
for.
you doing? It's some scratches. She was oh, come out.
Oh, yeah. Oh, yeah. You know, watch.
Now,
I
This
didn't-
next month or two.
I didn't. I didn't understand.
No, this girl, she came up to me in the bathroom, and she was like, "I like your hair. Is that your real hair?" I was like, "I don't."
Bro, I'm
Yes.
so.
I didn't even tell her it's not. Because
Oh,
I
they
feel bad
have
for
to
her. She didn't know it was mine.
I'm gonna cut my hair like Boba.
Hey,
I'm gonna cut my hair like Boba. Nice and shaved, big old poof on the
So I
top.
said I was gonna wear a wig, and somebody said they snatched off my head if I wore a wig, and I was like,
All right. So let's talk about these. Go back to your triangle.
are we not doing a heart?
Wait, I can't find my heart.
let's do this.
You should have traced your heart and then turned it.
I already did that.
Traced your heart and turned it. Hurry up. Turn it.
Turned it.
Trace it and then turn it.
Turn it out.
Oh,
Trace it.
have y'all seen the heart?
Turn it.
It's supposed to be upside down.
No, not necessarily.
Would you like to
Trace it
behind you?
and then turn it.
Would you do?
Oh.
With this?
Like that.
Okay, what about the
Oh,
I did it.
Bring
So,
down the rose.
The rudest person ever used it.
You're fine. It's fine. Right where it's at. You're fine. Right where it's at.
Thank you.
You said Frizzly?
All right.
You said Frizzly.
So our original figure, okay? Our original figure is this one. So they call this the pre-image. Once I've done the transformation, this is now called the image. So we've got a pre-image and an image. Can somebody tell me what transformation that is?
Reflection. Is it?
It's a reflection.
Reflection?
Yeah.
This is a reflection.
Oh.
And what this does is it produces a mirror image. And back in 8th grade, you should have called this your flip.
That's what I was going to say, but everybody was talking over me.
Oh, God, what a lie.
I was really going to say something.
Sure.
That's for y'all.
Eighth grade, I broke a mirror.
Okay.
Short.
So what happens here when you have a reflection? Your lengths of your sides stay the same. So if this bottom piece down here is a 3, that means the corresponding side over here is a 3. Okay? If this side of it is a 4, this side of your image is a 4. Yes. If this side is a 5, this side is a 5. Okay? So the lengths are preserved. They don't change. Something else that's preserved are your angles. If this is a 30-degree angle, this is a 30-degree angle. If this is a 90, this is a 90. And if this is a 60, this is also a 60. Okay, so your angles stay the same in a reflection. Your sides stay the same in a reflection. It just moves. Okay? No, just slide it.
So what if I just put it to the side of it?
That's fine. Okay? Your trapezoid. What kind of transformation is this? Slide. This one's actually going to be a slide. Okay? This is a slide. Does anybody know the actual math term for it?
Slip.
Translation. This is a translation. This is a translation. The object slides to a new position. Okay. Your object slides to a new position. So, side A and side A, side B and side B, C and C, D and D. Okay. So if you take a look at mine went to the right and then down. Some of y'all's just went to the right. That's okay. That's still a translation. It's still a slide. Okay. This is still your pre-image. And this is your image. Your angles also stay the same in a translation. So if this is W, this is W. If this is X, this is X. If this is Y, this is Y, and this is Z. Okay, so in a translation as well, your sides stay the same, your angles stay the same. So we've talked reflection, translation. What's my bottom one? Rotation. Rotation. The object is turned. Around a fixed point. Okay, we're only going to talk about rotations around the origin. Okay, but you can rotate around any point on the coordinate plane. Okay, this is again your pre-image, and this is your image. We don't really have side lengths and angles because this is a heart, but the same thing happens with rotation. Your side lengths stay the same, your angles stay the same. That's it for page 19. Okay, that page that I asked you to cut in half, we'll glue in on pages 20 and 21. And then that last little half page will glue in on 22 if you want to take a minute and glue those in. Does anybody still need this up? Hold on, I got you. All right, that full page that you cut in half will glue in on 20 and 21. And that other page will glue on 22. That's fine. Some people prefer to do beforehand, some people prefer to do after. Does not matter to me. I usually wait till after. But today, for some reason, I glued them in ahead of time. You like it or you don't like it? You do?
We were supposed to drop last Saturday.
Sometimes it just gives us a break from like problem.
Right, teachers be so like certain teachers be just so like, let's just do this word, let's just write these notes. I like the fact that we get no break from this wicker though, for real.
I do apologize too. It gets very hard to see this board in the afternoon because that sun beats in straight through those windows, which is why most of them are covered in orange paper to kind of block the light.
Should have covered it in black paper.
I was afraid to go too dark because then it's really going to make it hot in here.
Oh, never mind, yeah.
Go dark what?
On the windows.
Oh.
Cause, yeah.
The darker you go and the sunlight hitting it, it's going to roast this room. It's already hot enough.
Oh, Jesus.
All right. So, if you take a look at this picture, okay? You take a look at this picture. One, what transformation has happened here? This is a flip, which is a reflection. This is actually a reflection across the y-axis. Okay. If you look, the center of your reflection is the y-axis, which is what makes this the reflection across the y-axis.
So the two coordinates, that's what creates the function. For both.
Okay, so before we can do B, B says name the coordinates of the vertices of the image. First off, we've got to figure out which one of these is the image and which one is the pre-image. Which one of these figures is my original shape? The one on the left or the one on the right?
Right.
Is the
So
one
the
with
left
the
How many says right?
It's left.
Which one of those is How many say left?
I'm scared to be wrong.
It does.
Yeah,
It's
the
the
one
left.
that has that reverse dash
It's
on
the
left.
right.
That's what I said.
Okay, so if you take a look at this, and it's probably easier to see on your page than it is to see on mine. So if you take a look at this, the triangle on the right-hand side is ABC. The triangle on the left-hand side, it now has this. A prime, B prime, C prime. Okay, that prime means that one transformation has happened, which makes that your image. Okay, so your prime makes it your image. And yes, you can have a double prime. You can have a quadruple prime. Okay, so the more primes that I add, the more transformations that has happened. So in other words, if I have, if you see something like this, that means my original figure has gone through 4 transformations. They call this a quadruple prime.
Why wouldn't they put just 4? Because that's
Because that would technically raise it to the 4th power
Oh, yeah, right.
with exponents. So they use the primes to show transformations. Okay, so they want the coordinates of the image. So they want to know, where do I find the point A prime? Where is A prime? -4, comma, 0. -4, comma, 0. It goes 1, 2, 3, 4 to the left, and it goes up nothing. Okay. Where is B prime? -4, comma, 4. Bless you. And where is C prime? C prime and C are at the same point. So 0, comma, 4. And what would you say to C? Is triangle ABC congruent to its image?
Yes.
Yes. And you can put a reflection is an isometry. An isometry means that my figures are congruent.
So transformation would mean that they're nothing alike. Like they don't have the same.
A dilation. A
So like if
transformation.
it was turned sideways or something, that would be at different points.
But there's still an isometry. It doesn't change the size of it. The only transformation that's not going to be an isometry is a dilation, which we'll talk about later.
Are you still recording?
Okay. All right. Let's jump down here. Name and describe the transformation. What's happened here?
It's a reflection too, right?
This is still a reflection. Okay. This is still a reflection. My line of reflection, though, is right here.
Why is it between them?
Your line of reflection is the middle space in between your picture. Okay? So your middle line in between the picture, the line that would cut that in half, is where I just drew that line. So this is actually a reflection over x equals -1. Okay? Because this bold line right here is your y-axis. The line that I just drew goes through -1 on your x. X equals -1. Okay. Number 2 says name the coordinates of the vertices of the image. Okay. Which one of those is my image?
The one on
The ABCD.
it's the right one.
Oh wait, no.
Remember, image is after the transformation.
Oh, it's
So it's going to be the one on the right. When they don't use primes, your original is the beginning of your alphabet. After the transformation is the end of the alphabet or after the beginning. So this is your pre-image, and this one is your image. 0, 0. Where is F? 0, 2. Where is G? 2, 3. And finally, where is H? 2, 0.
Okay, now, never mind.
You good? Please feel free to stop me if you have questions.
How did you find G again?
So here's your origin here. G is 2 to the right and up 3.
How did you
So 2 in your X, 3 in your
How was
Y.
the reflection over X equals negative 1?
The reflection over X equals negative 1. Okay, so let me. This goes like this.
Right.
All right. If I would take this and fold it in half so they lie on top of each other, okay, that means my crease would be right here. And then it goes through negative 1 on your X, so it reflects over X equals negative 1. Basically, where would you fold your paper? Okay, does that make sense?
Yeah. So you trying to tell me that didn't move?
Like, it didn't move. If that's the, never mind. I don't know.
I'm just saying, if I fold this in half here, that means
No,
this
I
angle.
understand that. What I'm saying, the image moves.
Yeah, it folded over to the other side.
It folded over to the other side. So basically, I took this figure and threw it over here
Right.
and flipped it.
But it's not even.
You don't have to.
I'm trying to say, oh my God.
No. I'm trying to.
I'm not in the right mindset. But
What do you mean it's not even though?
because, okay, you said that's the image right there. On the right, that's the image.
Mm-hmm.
So you flip that and go to the other side. That's not even
I
because the
get what
line's
you're
right
saying.
there.
I get what you're saying.
I think she's talking about the amount of space.
The line.
The solid line, bro.
Oh no. So what if I get rid of this?
Then I understand. Yes, that's even.
Yeah.
The first one wasn't.
Okay, because it's not flipping over the y-axis, which is what I just erased.
Right.
This is the point that makes it even. That's what you're trying to find.
The negative one.
Yes.
Okay, I get that.
Okay.
But you don't have to put the line like that confused me. Yeah, I mean, it made my head hurt.
Yes, ma'am.
I got a headache now.
Okay, how did you know which one was the pre-image representation? How did you
When you've got the one like this without the primes, the pre-image is always the beginning of the alphabet, and then the image will come after that.
Oh,
Okay.
bro, I'm gonna go watch some.
All right. Name 2 angles with the same measure. So if I look at this picture, angle A has the same measure or is congruent to angle what?
Wait, hold up. What each? You just heard. Whoa.
Okay.
You did that fast.
When I, hold on. If I take my picture and I flip it, if A is on this side, when I flip it, it becomes what? H.
What's the L for?
That's angle.
Angle
A.
I thought that was an L.
I really need it.
Angle A, and that little swooshy equal sign means congruent. So if you need to put that somewhere on your page, that means. All right. So on the side of the paper, I want you to write this equals angle. This equals congruent.
thought I meant about.
No.
Oh, okay, first of all.
No.
Y'all wanna go home and eat, y'all understand.
I'm
That's just
always
me.
feeling angel. Your headphones need to be
Y'all wanna write your water.
Ooh, boy. It's the worst. When just one headphone stops working, you just keep trying to listen to it.
All right. Let's go back to this now. So, if you take a look at this, angle B should be congruent to angle what? G. B and G should go together. Angle C then is congruent to angle F. I heard somebody say it. And angle D then is congruent to angle E.
Are you? I'm just kidding. Are you really?
I said I
Feel like you. I didn't say I was.
then
I feel pretty with yourself. Does that mean I'm pretty?
it's not that funny.
No, remember earlier when you snorted?
Why would y'all bring that up?
Oh my God. It's like, it was like, I get it, Bill. I get
Miss Smith is
it.
picking on me.
I get it.
Craziness.
Wait, go back.
I snorted. Oh my god.
Never mind. Take a leave with her. Sorry, my butt hurt.
No, I remember.
Bro, my butt.
Yes.
No, I remember.
Yes. So now the entirety of YouTube
Bruh.
is all about Elena's butt.
Sorry, you.
All right. Remember, guys, let's finish this last page and then I'm going to let you guys do your pre-test so we can get that done and out of the way and we'll finish this up tomorrow.
What did it say?
Which means no homework tonight.
Hey!
Okay, so take a look at this. Okay. Which one of these are isometries and which ones are not? Remember, an isometry means same size and shape. So, is A an isometry?
Yes.
Yes. What transformation has happened? That's a rotation. Is B an isometry?
No.
No. This is the only one we really haven't talked about yet. This is a dilation. Is C an isometry?
Yes.
Yes. What is this? Reflection. Okay. So 1 is a rotation, so that's a yes. 2 is a dilation, which is a no. And C is a reflection, so that is a yes. Okay, we're going to do the same thing for example 2 at the bottom. What about 4? No. That's a dilation. And 5 is a yes. That is a rotation. Yes, that one is a rotation. Okay, we are going to stop there for today. Those of you that did not finish your pre-test on Canvas, I need you to get into your computer and do that pre-test now. That last page that we did not get to, please glue it in on page 22 so you do not lose it, or put it somewhere so you do not lose it.